Here we have a problem on derivative. There is a function given over here and we have to find dy over dx. Actually, this is implicit function because this function is not solved for y in terms of x. So for example, let's consider a function y is equal to x cube 3x square, something like this. Actually, in this function, it is solved for y in terms of x. So it is called an explicit function. But in our problem, the function has not been solved for y in terms of x. So it's an implicit function. Anyways, so we have to find the derivative on both sides of the function with respect to x, and then we have to solve for dy over dx. Okay, first let me write the given function as it is. That is tan of x positive y equals to x. Now let's differentiate on both sides with respect to x. Okay, already we know that the derivative of tan is just secant square, and whatever stuff we have here, it has to be written as it is. So whenever I find derivative of the trigonometric ratio tangent, trigonometric function tangent, so what I need to do is I have to write secant square, and the stuff we have over here should be written as it is. So far I have completed derivative only for this tangent. By chain rule, I have to do further derivative for this x positive y. Okay, when I do derivative of this x with respect to x is just 1 positive. When I do derivative of this y with respect to x is just dy over dx. On the right side, if I find derivative of this x with respect to x is just 1. Okay, now what we can do is our aim is to get dy over dx. So for that, first let's get rid of the secant square of x positive y. For that, I have to divide both sides by secant square x positive y. Let me do it 1 over secant square of x positive y. Okay, this secant square x positive y, secant square of x positive y will cancel out. I'm getting 1 positive dy over dx on the left side. And so already we know that so using the reciprocal trigonometric identities, that is cosine x is equal to 1 over secant x. So if I have 1 over secant square x positive y, then what can I write for this one? So I can write cosine square of x positive y. So if I have 1 over secant x, I'm just writing cosine, and whatever stuff I have here, I'm writing it. But here I have secant square in denominator. So I have to write cosine square, and whatever stuff I have for this secant square, the same should be written for this cosine square. Okay, so to solve for dy over dx, I have to get rid of this 1 over here. So for that, I have to subtract 1 from both sides. So when I do so, this positive and negative 1 will cancel out. I'm getting dy over dx equals to cosine square of x positive y negative 1.